Okay guys, so here's the guide video for this one. So let me write guide video. Okay, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Okay, so this will be our initial amount. Customers remove bananas from the display table at a rate modeled by this for time between 0 and 12. Where F of T is measured in pounds per hour and T is the number of hours after the store opened. All right, so this would be the rate out. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by this. Okay, so this would be the rate in. Where G of T is measured in pounds per hour and T is the number of hours after the store opened. So part A, how many pounds of bananas are removed from the display table during the first 2 hours the store is open? Okay, so, all right, so what we need to know for A is that the amount out is going to be equal to the integral of the rate out. Okay, so I'm just going to do the integral from 0 to 2 of f of t, dt. All right, and then you've got to do math 9 in the calculator. So math 9, and you have to be in radians, which I am. And then, so it's from 0 to 2, and then 10 plus 0.8. Okay, 20.051. So 20.051 pounds of bananas are removed in the first 2 hours. Okay, now part B. Find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. Guys, when you're on a calculator section, in a situation where you're trying to find like an integral over a given interval or a derivative at a certain time, you could use math 9 and math 8. Okay, so it's math 8 for derivatives. So f prime of 7. So I go math 8. All right, here I'm going to plug the function in. So 10 plus 0.8x. Okay, evaluated at 7. Okay, so I get negative 8, negative 8.120. Okay, if I'm rounding up, okay, because the 9 rounds up. So this would be, so it's like a rate of a rate. So this is going to be pounds per hour. Okay, so this is we're doing the rate of change of the pounds per hour. Now guys, when it comes to rounding on the free response section, you could also like not even round up. So if you said negative 8.119, you'd also get credit. Okay, so on a free response problem, you can round up. They want 3 decimal places, but you could round up or have it stay the same. All right, now we've got to explain like the meaning of this. So a derivative is the instantaneous rate of change. Instantaneous rate of change means like at a given moment. All right, so this is not going to be the rate of change like during the 7th hour. It's going to be the rate of change like at the 7th hour. So we're going to say after the store, I guess in the context of the problem. So after the store has been opened or open, has been open for 7 hours, the rate at which bananas, the rate at which bananas are being removed from the table is, okay, so is it increasing? So I'm explaining like the moment that we're concerned with. So the moment is after the store has been open for 7 hours. And now what is changing? The rate at which bananas are being removed, that's what's changing. So the rate at which bananas are being removed from the table, that's what's changing. So that's F. Is it increasing or decreasing? Decreasing at a rate of 8.120 pounds per hour per hour. Okay, I don't need to say negative here because I've already said decreasing. So the decreasing is what implies the negative. So A, B. Now C. Part C. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. So we're looking for, so if something is increasing or decreasing, its derivative is positive or negative. So this is like a Susan's table thing. So the number of pounds of bananas, we want to know if the derivative of the number of pounds of bananas function is positive or negative, basically. So I'm going to do this. I'm going to let B of t equal the pounds of bananas on table. Okay. Then B prime of t, this is going to be the rate in minus the rate out. So B prime of t, the rate in is G of t, the rate out is F of t. All right. So B prime of 5. B prime of 5 is going to be equal to G of 5 minus F of 5. And then you just type that into your calculator. You don't need Math 8 or Math 9. These are already the derivatives. So you're just typing 5 in. So G of 5. All right, so I do 3 plus 2.4 natural log. 25 plus 10 is 35. Minus, or that's the rate in, now the rate out, I need parentheses around it because I'm subtracting the whole thing. 10 plus 0.8 times 5 sine 5 to the third over 100, double parentheses, equals negative 2.263 pounds per hour. Okay, now I gotta say if B of t or B of 5, or yeah, I gotta say if B of t is increasing or decreasing at this time. So I'll say decreasing because B prime of 5, which is equal to G of 5 minus F of 5, is less than 0. Okay, So that is part C. Now part D. How many pounds of bananas are on the display table at time t equals 8? Okay, so D, all right, so I want B of 8. That's what I want. Guys, I don't have a function for B of t, but I do know B prime of t. I just kind of said it right here. So I know B prime of t. So if you want, so we basically want the antiderivative, so you could use the antiderivative with an integral formula. So B of t is equal to B of 0 plus the integral from 0 to t, B prime of w, dw. Okay, now I'm just going to start filling in things that I know. B of 0, do I know the number of bananas on the table at time 0? I do. 50 pounds of bananas on the display table when a grocery store opens. So this is telling us that B of 0 is 50. Okay, so 50 plus the integral from 0 to t, B prime of w, dw. Okay, now guys, B prime, oh yeah, actually, I could have done this right now. So B of t, and you could do this much in many less steps than me, is 50 plus the integral from, no, B prime of 8 is what I want. No, B of 8, my bad. So B of 8 is 50 plus the integral from 0 to 8, B prime of w, dw. Now guys, B prime of t, that's going to be rate in minus rate out. Okay, which I already kind of set up here. Now, at time 5, the rate in is g and the rate out is f. But here we're looking, when you're doing an integral, you're doing it over an interval. So over this entire interval, time 0 to 8, the rate out is f. But the rate in is not always g. Okay, this rate in of g does not take effect until the 3rd hour. So for the first, so from 0 to 3, the rate in is going to be nothing. Okay, so basically I'll just say it like this. So this is going to be equal to 50 plus the integral from 0 to 3. Rate in is 0 minus rate out is f. F of w dw plus the integral from 3 to 8. Now at this point, the rate in is no longer 0. The rate in is g. G of w minus f of w dw. Okay, and then you just plug this in your calculator. Now guys, this, if you plug it in your calculator like this, you will need like 0 minus and then parentheses around the f function. And if you forget those parentheses, you're going to get it wrong. So I think a better way of writing this is 50. Now 0 minus something is just negative, that thing. And you could pull the negative out front. So it'd be 50 minus the integral from 0 to 3. And then you don't have to worry about like any parentheses being messed up. Okay. Now I'm going to type very carefully into my calculator. So 50 minus math 9, 0 to 3. And I'm typing in just f. No. 10 plus 3. Okay, dx plus math 9, 3 to 8. I'm typing G in first. 3 plus 2.4 natural log. Okay, minus, now you need parentheses around the entire f function. So 10 plus 0.8. Okay. There it is, 23.347 equals 23.347. This is pounds of bananas. There are that many pounds of bananas on the table at time 8.